afternoon, everyone. Is the audio okay? Can you all hear me? This thing. Yo. 1, 2. Hello. Afternoon, everyone. Is the audio okay? Can you all hear me? Well, good afternoon, everyone. How are you all doing? Okay, alright, so today we'll be going through the basics of algebra, so things like first of terminology, because that's really important, just basically what makes up algebra, and this is a good basis for, or this is the basis for everything you'll be doing from grade 8 onwards. Yeah, so we'll be going through the terminologies, we'll be going through the different operations with algebraic expressions. There's just a lot of intro. So yeah, we'll get started. So first thing is the terminology, and now the terminology is just the words we use in algebra to refer to certain parts of let's just say sum for now. So the most important thing about algebra, and the newest thing for anyone starting it, is the variable. Now variable just means that it's a letter of some sort, most popular being x, a letter that is unknown. So this letter can be any possible value, and the reason why it's called a variable is because it can change. Doesn't matter what the value really is. So with that being said, a variable can be any usually small letter. So we can have x. X is the most common one, but we could also have y. We could have a, b. It's just any unknown, or sorry, any small letter, and it's just an unknown variable, right? And it's called a variable because it can change depending on what that value is. Next we have the constant. So constant is just the term with a fixed value. It doesn't change. It doesn't change, and this is because it does not have a variable. Like I said, variable can be any unknown value. Constant does not have a variable, so it can only be that. You can also just think of it as the number. It'll just be a number on its own. It won't ever change. 7 will always just be 7. So term are just a combination of variables or constants that are usually separated by plus or minus signs. So for instance, the term of 7x. So all this is, when I say identify the second term here, the second term will be 3x. Again, these are usually separated by plus or minus. Now one more term here, let's do 4y. Importantly, terms can also be separated by a set of brackets. So whenever you see a bracket, everything that is inside those set of brackets is considered one whole term. You shouldn't try and dividing one part or adding just one part. You should look at that entire bracket as just one entire term. And this is something that's going to become very common as you do more algebraic expressions. So 7x, 3x, 4y, all of these numbers here are called the coefficients, or the coefficient. So the coefficient is just the number in front of your variable. So let's say we have x, y, we have 7, and let's say we have 4 again. Why not? Okay, so the coefficients for each of these here, the coefficient of x will be 7, and the coefficient of y will be -4. So importantly, whenever we have a sign and we want to identify the coefficient, it's important that we include that sign. If there is, for example, let's say a plus 5a, you don't necessarily have to say that the coefficient of a is plus 5, but you wouldn't be marked wrong either. But if you don't include the plus, just remember that just is a positive number. However, when it comes to negatives, you have to specifically include the negative, so just maybe get into the habit of looking at the sign in front of the coefficient. So next we have the degree. So a degree is just the highest exponent in an algebraic sum. So in this case here, this expression or the sum is to the 3rd degree, because it has the largest exponent here is to the power of 3. This number right here. Questions that is usually asked around the degree is identify what's the degree of this expression, or rearrange the identity or the sum from descending powers or ascending powers of x. So all this means is, if we have the let's not use x, let's use y to the power of 5 minus y to the power of 3 plus 3y to the power of 7. If we have to rearrange this one in ascending powers of y, this means that we should start from the lowest degree or the lowest exponent. So in ascending form, it will be y to the power of 3. Importantly though, we have to include the negative in front of it, because this entire term right here is -y. So again, get into the habit of using the sign that is directly next to the variable or coefficient. So that's minus y to the power of 3, and the second biggest one is plus y to the power of 5. So like I said, if there's no sign there, you can just consider that positive. But if we are rearranging, we just have to remember that this y is positive, so it becomes plus y. And then the last one we have is again plus 3y to the power of 7. So even though 3 is the biggest coefficient here, we are not looking for the biggest coefficient, we are looking for the biggest exponent. So the exponent again is just a number on top of the y here. So with expressions, algebraic expressions, an expression, like I've been saying sum the whole time, it's just another word for sum basically. So they will usually say something along the lines of for this algebraic expression, it's just basically a sum. So yeah, these are the terminologies that you'll be using from now until grade 12 or till when we even do university math. These terms won't change. These are just the standard way of doing things. So again, variable is just an unknown value, and it's usually represented with a small letter. Next we have constant. Constant is just a number without any variable, because again, variables can change, can be any value, but a constant will stay the same. A term is just it's combinations of either variables or constants, and it's usually separated by a plus or minus or a bracket. So again, with brackets, you need to remember that anything that's inside the bracket is considered one whole term. So this entire bracket in this case here is one term. And this is going to become really important when you do expressions with fractions. Okay, so then coefficient is just the number in front of your variable. So 7 is the coefficient of x, -4 is the coefficient of y, and +5 is the coefficient of a. And again, signs are going to are really important, so always include them. So that's why I say the coefficient of y is -4. Degree is just the highest exponent or biggest exponent. So in this case here it's going to be 3, and the question that they're going to ask is rearrange it from in ascending order or descending order. And ascending means from smallest to biggest, while descending means from biggest to smallest. And then expression is just another word for an algebraic sum. So this is just your sum here. So let's take an expression and answer a few questions about it. So we have x5 plus x to the power of 2 minus x squared over 2 minus 4 plus x. Plus x. So again, this is just an expression, and this term, and this expression here in particular, it's just referred to as a polynomial. So a polynomial is just an expression that has multiple variables and constants. That's the way you can think of it. We'll get into binomials and trinomials later, but polynomial is just a way of saying that there's multiple terms, without specifying whether it's 2 or 3. So first thing we need to identify here is the variable. So the variable for this expression, in this case here, will be x. X is the variable in this expression. These are the things that are unknown. So the variable here is x. The number of terms in this expression is, again, we want to look at the pluses and minuses and think of those as splitting up the terms. So we have 1, 2, 3, 4, and 5. So we have 5 terms. Next we need to find the coefficient of mistake there, it's x to the power of 3. So let's find the coefficient of x to the power of 3. So x to the power of 3 is on a fraction right here. It's all over 2. So let's just write down an example of a quick fraction example. So remember, when we have fractions and we're multiplying them, specifically if we have just a number, so let's say 3, actually that's not there, so let's do 4 times 2 over 5. So in this expression here, all we have to do is multiply the 4 by the 2, and that will give us the answer of 8 over 5. Because when we multiply fractions, we just need to multiply numerators and denominators. So this will tell us what the answer will be for the coefficient of x to the power of 3. So using this, we can also rewrite negative x to the power of 3. Actually, let me do that underneath. So my term is negative x to the power of 3 over 2. We can rewrite this as negative a half x to the power of 3. Right, it's the same thing. Because again, when we multiply something that doesn't have a denominator, we just need to multiply the top. Right, so we'll just multiply the x to the power of 3 by the 1, and this means my coefficient for x to the power of 3 will just be negative a half. And again, because this is over this is just x to the power of 3 over 2, which we can rewrite as negative half x to the power of 3, and they don't expect you to show this step. But they won't deduct marks from you if you were to show it. So show it, it's better to have the right answer and write too much. But the answer here is negative a half. So next, the degree of this expression. So again, degree is just the largest exponent in our expression. So in this case here, it's x to the power of 5. So this is in the 5th degree. And whenever we say degree, you can always just refer to it as the 1st, 2nd, 3rd, 4th. So 5th degree, you can also say, no, you can only say 5th degree. So lastly we have the constant. So the constant in this expression here is the one without a variable. So no variable. The only one that has no variable in this entire expression here is negative 4. So again, don't forget you have to include the sign as well. So the constant in this expression is negative 4. And if you're in grade 8, you probably came across a sum like this this term. If not this term, then you'll definitely do it next term. And this is basically always the format of these sort of questions. They'll give you a polynomial or an expression, and they'll ask you to identify different parts of it. I can't guarantee that it'll be the exact order, but this question is very common for grade 8. So there's one more question we'll do, and that is determine the value if x is equal to, let's say, negative 1. So determine the value of the expression if we say that x is equal to negative 1. So don't forget that x is just a variable, and like I said, variables can be any number. This also means that they can just if they give you a certain term or expression, let me do that real quick. Okay, yeah, so if we have a certain expression and they say that the variable is given to us as a certain value, so in this case we have x is equal to negative 1. This just means that wherever we see an x, we have to put a negative 1. So this just means that in this entire expression, regardless of what's in front of it, what it's over, what's next to it, you have to just say negative 1. So I specifically chose negative 1 because substituting terms into an expression can be tricky, especially with negatives. So let's first do it with a small example. Let's say we have y plus 3y minus 2y. And we say that y is equal to negative 2. So what this means is, actually y squared. So what this means is we have to substitute wherever we see a y with a negative 2. So in the first one here we have y to the power of 2. So instead of writing y to the power of 2, we will say negative 2 to the power of 2. And that bracket is very important. This bracket specifically shows that it's the entire variable of y to the power of 2. If you were to just say negative 2 to the power of 2, then what this actually means is that you're only saying that y is equal to 2 and you put a negative in front of it. I know it seems like a small thing, but especially if you tend to rely on your calculator, this will give you an incorrect answer. So always use the brackets when you substitute. That's the best way to get the correct answer, especially if you're going to end up using a calculator. So next we have plus 3y. So this just means that we have to say 3 bracket negative 2. That one's going to be substituted, and also we have 2 bracket negative 2. Okay, so it's a bit of multiplication here with negatives. When you do BODMAS, you'll do this, but when Malik does BODMAS, you'll do this a lot more. But we have a negative to the power of 2, so this just means that if you put this in the calculator, or if you write it out completely, this will just give the answer of 4. So 3 times negative 2, brackets just mean multiply, so 3 times negative 2 gives us negative 6. Negative 2 times negative 2 gives us positive 4. So 4 minus 6 is equal to negative 2 plus 4. Negative 2 plus 4 is equal to 2. So again, when you substitute, make sure to include brackets, because that's the best way to guarantee that you'll have the correct answer. And it's small things like not including brackets, which could cause you to mess up on a negative, which unfortunately when it comes to algebra, it will topple down to the rest of the sum. Usually with algebra, the first thing is the first mistake is what knocks onto the rest of the sum. So always make sure that your first step is correct. That way you can just guarantee that you're doing the right thing at each point. So for this one here, we have x to the power of negative 1. Let's move it to the side here, but there we go. So determine the value of the expression if x is equal to negative 1. So it's just substituting. That is x to the power of 5. So we'll say is equal to bracket to the power of 5, negative 1 to the power of 5, plus, again, put your brackets, power of 2, negative 1. So you can immediately just write your brackets down wherever you see the x and just fill in what's around it basically. So for the next one is x to the power of 3, so this just means that to the power of 3 goes in our numerator, still over 2, and the thing that goes in the brackets is still going to be negative 1. Minus, what's 4? A constant, because that now will not change. Right, again, constants do not change because they simply don't have a variable with them. So 4 in this entire expression is just going to remain 4. If x was equal to 3, then this will be 3 to the power of 5, 3 to the power of 2, 3 to the power of 3 over 2. This will still be minus 4 plus 3. So constants remain constant. So just some work here, or brain math here. So negative 1 to the power of 5 will just be negative 1. Positive 1 to the power of 2 will just be positive 1. Now negative 1 to the power of 3 will just be, I'm keeping this negative right here. Negative 1 to the power of 3 is just going to be negative 1 all over 2. Minus 4 plus negative 1, that just becomes minus 1. So with this fraction part here, whenever we have a negative in one part of our fraction, whether that be the numerator or denominator, that actually makes the entire fraction negative. Right, so this entire fraction is just going to be negative. But since we're minusing this negative here, this will not change my answer from minus negative half to just plus half. plus a half. And at this point you could just get a final answer, and that will be the marks after you add everything up, which again you'll do more as you do part maths with negatives, and again negatives are really important, especially when it comes to algebra, because those rules still apply here. Yeah, so again, this sort of question is almost guaranteed to come into your grade 8 exam. If not for term 2, then definitely for term 3, and most definitely for term 4. So they'll give you an expression and they'll ask you to identify different parts of it. And they might also ask you to substitute a number in, but again you just need to make sure to properly include negatives, and whenever you substitute with brackets. So I'm going to do 2 more substitution examples, mainly because again they'll probably focus on a substitution question just on its own, or they can ask it as part of this. So let's do -6/3 plus 4y minus 3. So it's the first one. Determine the value of this expression if x is equal to 2 and y is equal to 4. So now we have 2 variables that's given to us, and we are given the values for both of them. So one thing I didn't mention yet is, what is this combination of numbers and variables? Again, this is just a term, but what this term actually is, 4y is just equal to 4 times y. Whenever we have a number and a variable that are next to each other, it simply means that they are multiplying. Right, so the same thing applies to negative 3xy. Negative 3xy is the same as negative 3 times x times y. So you need to take this into consideration, especially when substituting more than one variable. So in this case here, we have negative x to the power 3. So again, I'm just going to write everything that's around the x first. So to the power 3, and put that in brackets. So I know x is equal to 2, so I'll write 2. Plus 4. And then what's y equal to? Y is equal to 4 as well. So that will just be multiplied. Minus 3. I'll write 2 brackets here because I know that I'm substituting for both x and y. So x in this case will be equal to 2 and y will be equal to 4. Let's put it color coded actually. Okay. So now it's again just calculating what this is. So whenever we have a negative outside the brackets, that just means you need to deal with whatever is inside the brackets first. So 2 to the power of 3 is just going to be 8. So this will be negative 8, negative bracket 8, plus 4 times 4 is just going to be 16. And when it comes to this one here, we have negative 3 times 2, which will be 6, times 4. So you can either choose to do that entire multiplication sum in one step, or you can do it in 2. Just remember though what you do multiply. Whatever you didn't multiply, bring it down. So negative bracket 8 we can just rewrite as just negative 8 plus 16 minus, so 6 times 4 is just 24. And again, don't forget the negative 24. So again, if you haven't worked with something in the sum, you just need to bring it down into the next line. That is really important because again, the next line is equal to the previous one. So you have to always make sure that whatever you didn't work out with, if you didn't multiply, if you didn't add anything, just bring it down into the next part of the sum so you can continue answering it. So negative 8 plus 16 is just going to be 8 minus 24, and that will be 8 minus 24, negative 16. So again, the actual math of it is just all the work that you've probably done, but the substituting is where the mistake happens. So always make sure to substitute with the brackets, because that's the best way you can avoid substituting incorrectly. Yeah. So next part of this work is like terms and unlike terms. So a like term just means that it's the same. Yeah, it's not stuff space there, so let's do it here. Okay. A like term like just means the same. So how do we know when a term is like? The two things that you have to consider is the variable or variables, so there can be more than one, and the exponent of the variable. Okay, so these are two things you always have to consider when trying to identify if something is like or not. So, take an example of x plus y. Simple enough. X plus y. X is not the same as y, and y is not the same as x, so these aren't like terms. So this will just stay x plus y. Right, so you cannot put them together. Next we have, let's not do x all the time, let's do a plus a b. So let's say 3ab. And so now we have a, ab, and 3ab. So in this case here, the like terms are, even though they all contain a, they aren't all the same, they aren't all like terms, because this is AB, this is AB, or this is just A on its own. So whenever we have two letters together, that again is considered a term on its own. So you want to make sure that the terms that you are putting together are actually like. And this is just an A, this is just an A, this is just a B, this is just a B. So these two can indeed be grouped. So it will be plus AB plus 3AB. Any term that doesn't have a number in front just has an invisible 1. So 1 plus 3 is just 4. That'll be 4AB. Oh, hi, cool on. Sorry, I was focused. Yeah. So, like terms, you need to look for the same, either the same variable or the same exponent. So let's do one more with, let's do AB again. So A squared plus B squared plus 2AB minus okay. So this is a bit of an extreme example, but it does test everything. So again, now we need to look for all the like terms, and we can, and when something is like, is when it's the same variable or variables and the same exponent. So if we look at A, we see that A to the power of 2, so this needs to be grouped with another A to the power of 2. And like here, this is the only other A to the power of 2 here, and that is negative 3. So 1A squared minus 3A squared gives us minus 2A squared. So B squared, is there any other B squareds here? No, this is just a B on its own, so this cannot be grouped. 2AB There are A's and B's everywhere, but nothing is specifically A, B as one term. So this just stays on its own. And lastly, 4b, there's nothing else, it's just a b on its own. This is a b squared, and this is just a b, so this will remain as is. So this is where the sum is considered done, because there's nothing else we can put together here. So always make sure to look for the variable or sets of variables. It can be 2, it can be 3 different variables, and the exponents. Don't forget the exponents. Even when you write it down in your book for the answer, if you don't include that exponent, you will probably group it incorrectly. So always make sure to include the exponents. That's one thing about terms and multiple variables in a term. 3 x, y, z is the same as z 3 y x. It's just a bit this is just a bit weird to look at it. The second one, it's z 3 y x, but this technically is still the same thing, because again, terms consists of numbers and variables, and these are all just being multiplied. So we can also just rearrange it to make it look a bit more neat. So z 3yx, you can just rewrite as 3xyz. They're still the same thing. It's just rewritten in a different way. This is a means though that when you do end up in a situation of let's say 2xy plus 4yx, this means that you can add them. They don't look the same, but they actually are like terms. It's just that this one is in alphabetical order while this one isn't, so it's just rewrite it in alphabetical order, and there we go, we have like terms. So if ever you can't spot a like term, but you can see they sort of consist of the same letters, just rearrange the letters in that own term here and see if you can get a like term, or if you can spot it more easier. So the final answer is 6xy. There's also no wrong way to write the order there, unless it specifically say put in alphabetical order. So if you wanted to, for instance, instead of saying 2xy, you could then instead say 2yx. That's still correct. It's still the same thing. It's just that usually we write things in alphabetical order. 6yx is the same as 6xy. Yeah, so like terms, again, it's going to show up everywhere from when you do algebra. It'll show up in later grades as well. It'll just probably come a bit later in the sum. So now we get to adding and subtracting expressions. So there's two ways they can do this. They can either just give you two expressions to minus or add, or they'll give it to you in the form of a word sum. So before we actually start with that, let's look at words like add and subtract. So we all know what add and subtract is, just putting together or taking away, but importantly, it's the words that we use in conjunction with these. So we will usually say add to, and we usually say subtract from. And this is really important when it comes to those word forms of these questions. Words like to and from, always look for those words, because that usually tells you where you start. For instance, add 3 to 5 versus subtract, let's say 6 from 8. So if we add 3 to 5, we're saying we're taking the 3 sorry, we're taking the 5 and we're adding it to the 3. So like with addition, it kind of doesn't really matter the order you'll place it, because you'll still get the same answer, because 5 plus 3 is the same as 3 plus 5, but it is extremely important when it comes to minusing. So subtract 6 from 8. If we subtract 6 from 8, this means that from 8 we'll be taking 6 away, and this will give us the answer of 2. This is where the word from is extremely important. If you were to say 6 minus 8, 6 minus 8 is actually going to give us -2, and that is the incorrect answer. So when it comes to subtracting, the most important word there is from. Okay, so let's do a few examples. Let's say add 5x plus 2y and x minus 3y. So if we add these two, again with addition it doesn't matter really the order that you place it in, just that you make sure to add them correctly. So there's two ways we can do this. We can either do it in one line, or we can do it in the addition format of just writing things on top of each other. I'll do both. So if we're adding 5x to 2y, 5x plus 2y and x minus 3y, we'll say that it's 5x plus 2y plus x minus 3y. So 5x plus 2y. Can't really group anything there that's like, so look for your like terms as soon as you do the step. 5x and plus x just gives us 6x. 2y minus 3y will give us minus y, and that is our answer. So note how this negative here, even though we're saying we're adding the two terms, we are considering this entire term as one whole thing. So the 5x plus 2y we consider one term, and the x minus 3y we consider one term, and we're just adding them. But that just means that whatever the sign is, we need to do whatever the operation is of that sign. So the final answer is 6x minus y. So the other format you can do as well, it's both the same answer. So we can say 5x plus 2y added to x minus 3y. So with that, 5x plus x will give us 6x minus 2 minus 3 gives us minus 1y, or just y. So importantly, whenever you write this down, you want to make sure that you're writing the like terms directly underneath each other, because that is how you know, or that is how you add things. So you can either do it in one line and look at them individually. You can also rearrange it if you like. So there's nothing wrong with taking this expression right here and rearranging it in the format of 5x plus x plus 2y minus 3y. So you can rearrange it such that the like terms are all next to each other. So then we still get the same answer of 6x. 2 minus 3 is minus 1y. So both methods are fine. You just need to make sure to correctly group the like terms. So let's do another one. Let's say 2, 6a minus 4b, add 7b minus 5a plus 2c. So I'll do both methods again. So 2, 6a minus 4b add 7b minus 5a plus 2c. So we're taking 6a minus 4b, and we are adding 7b minus 5a plus 2c. So what I'll do is I'll rearrange this such that the like terms are all next to each other. So we have an a here, the other a is the negative 5. So we'll go 6a minus 5a, and the next term we have, or the next variable we have, is b, so we'll say minus 4b. The other b is the 7 right here, so we'll say plus 7b, and the only other term left is the 2c, so we'll bring that down. So even though we didn't do anything with the 2c, we still need to bring it down, because again, this line is equal to the previous one. We're just rearranging it. And now in the next line, we're actually going to do any grouping that we can. So I put the 6a and minus 5a together because they are like terms. So 6 minus 5 is equal to a, or just 1a. Next we have minus 4b plus 7b. So minus 4 plus 7 gives us plus 3b. And lastly we have the 2c. You just bring that down. Even though we did absolutely nothing with it, it is still a part of the sum, and we need to make sure to just bring it down each time. If we don't bring it down, that isn't the correct answer. So always bring down something, even if always bring down a term, even if you haven't worked with it, and bring it down exactly as is. And now this is your final answer here, because there are no other terms we can put together. So the other method of writing on top of each other, we then can say 6a minus 4b plus, now you see here we have 7b and minus 5a, so let's just write the a or the 5a underneath it. So we'll say minus 5a, and then we'll put the 7b next to it, so plus 7b, and we can say plus 2c. So importantly about this plus minus here, this is perfectly fine because this plus applies to each term. So this just means that 6 plus minus 5, we can just rewrite it as 6 minus 5. So 6 minus 5 is just a, and then minus 4 plus 7, minus 4 plus 7 is just going to be 3, so we'll say 3b, and again we aren't doing anything with the c, so we'll just bring that down. And that is the final answer. Both is acceptable. You just need to again make sure what are like terms and watch for those negatives. And again, addition is a bit easier than subtraction, mainly because you don't have to worry too much about signs and stuff like that. But when it comes to subtraction, it is also the one they most like to ask. Let's do a subtraction example. So from 2a plus 6c subtract 2a minus 3c. So again we want to look at the word from. So from 2a, this just means that we start with 2a. We're taking away from it. So from 2a plus 6c, we are subtracting, we are subtracting 2a minus 3c. So again, I want you to consider this entire term, or this entire expression here, as one whole term. So what we're doing is minusing this entire term. Actually, I'm not sure if blue is too visible, so I'm going to write that in yellow. So we are subtracting this entire term of 2a minus 3c. And so let's just bring this down, because we're not really doing anything with 2a plus 6c right now. But now we need to take into consideration this negative and this bracket here. So this is a bit of something we'll do next. But all we need to do is bring this negative into the brackets. And for that we just need to apply rules of multiplication when it comes to negatives. So a negative times a negative gives us a negative. So negative times 2, which is positive, will just give us minus 2a. Right, so that's this part. Now we need to take this negative and bring it into the 3. So this negative will change that sign. So negative by negative gives us a positive 3c. So now we have successfully subtracted correctly. So let's just do some rearranging so that we can subtract it easier. So 2a. There's another a here, so we'll say 2a minus 2a. Then with the C, we have a 6C and the 3C here, so we'll say plus 6C plus 3C. So this will give us the answer of 2A minus 2A will just give us 0. And 6C plus 3C will just give us 9C. So the answer will just be 9C. So again, negative or subtracting is the one they most like to ask because it is a bit trickier and it is where you have to keep an eye out for that bracket. And again, you can do both methods for this one. So maybe it's a little less brackets, but it is still the same amount of work basically. So if we want to write it in this format, plus 6C, what we have to do is minus this term. So what we're going to do is we'll take this term of 2A minus 3C. We're subtracting the entire term, so we'll say minus 2A because this is just a positive 2. And then we'll say this is minus 3C, so then this now needs to become positive 3C. Because a negative and a negative makes a positive. So 2A minus 2A will just give us 0. And then plus 6 plus 3 will just give us plus 9C. And so that is why subtraction is the one that asks most likely, because it does involve a lot of sign work. And always focus more on your signs rather than the numbers themselves, because that is where you're most likely to make a mistake. Obviously don't write the incorrect number, but focus on that sign, because that always tells you the order, or sorry, the operation that you should be doing. So a negative will just change a positive into a negative, and a negative will change a negative into a positive. So another example. Oh, and again, the wording, from 2A plus 6C subtract 2A minus 3C. So from 2A, which means we start with 2A, from 2A plus 6C subtract 2A minus 3C. So always take note of the word from. Always start from. So another example, 7p. So next one is subtract 7p minus 8 from 10 plus 17p. So the word from again just means we need to start from this one. So we'll write 10 plus 17p first. And what we're doing is we're subtracting 7p minus 8. Now this is the entire term, so we'll just put that in brackets. 7p minus 8. So we are subtracting this entire term from 10 plus 17p. Alright, so again we need to bring in the negatives. Let's just leave this 10 plus 17p as is. We're not doing anything with it just yet, so let's bring it down. And now we need to take note of what the negative does to everything inside the brackets. So a negative and a positive makes a negative, so this becomes negative 7p. And a negative becomes a positive, so it becomes positive 8. So again, the negative work is the most important thing here. So now let's just group sum. This is a constant or a number without a variable. So there's only one other number without a variable, and that's 8. So we'll say plus 8. Next we have the p, so we'll say plus 17p. There's only one other p here, so that's minus 7p. And just going to answer this, which will be 10 plus 8, 18. 17p minus 7p, so we just say 17 minus 7 gives us 10p. Okay, so again, the actual grouping isn't that hard, it's just the bracket and negative work you need to look out for. The other method again, since we're the word from just means we start from that, So 10 plus 17p, oops, we are subtracting 7p minus 8, but since 7p was positive, it will now become negative 7p, and negative 8, since we're bringing a negative in, we're going to say positive 8 instead. So it's a bit harder to see with this method what to do with your terms, but you always need to make sure to bring that negative into account. So actually let's rearrange this a bit as well. So it's negative 7p, I'm just going to write afterwards. Where's the... sorry about that. Yeah. So negative 8 will become positive 8, and 7p will become negative 7p. So it will be 18 plus 10p. So this method is a bit more confusing when it comes to minusing, so I don't recommend this method. I recommend this one, because this clearly shows you a brackets. So always put your brackets down when you are subtracting that term. Right, are we all good on that? Okay, so in algebraic expressions though, you still can't get away from fractions. Fractions will definitely still show up. So basically just if you have if we have the sum of y over 4 minus 2y over 5, you still need to apply the exact same rules. You still need to apply the exact same rules when it comes to... oh, what the hell? I stopped streaming? I'm like the stream stopped. Oh, never mind, so yeah. It stopped. You still need to apply the exact same rules when it comes to... no, it's okay, so something said stream ended 6 seconds ago. No, that's fine. Okay. Sorry about that. Yeah, so you still don't get away from fractions even when it comes to algebraic expressions. The rules will still apply though, the exact same rules that you were doing in fractions before. So you still have to find a common like base. So in this case here it will be 20. We have 20, 20 for each of them. We're still minusing. So 20 times what? Oh, sorry, 4 times what gives me 20? That is times 5. So we have to multiply y by 5 as well. And any letter number multiplying will just give us those two together. So 2y times 4 will just give us 8y. So with that, let's do some, oh, and then you're just going to answer for this one. So it would be 5y minus 8y, which will give us minus 3y all over 20. For that, let's do some multiplications in expressions now. Oops. So when we multiply terms, it doesn't matter what the variables or numbers are. We can just multiply them as is. Because what multiplication does is it forms one term. So 3y times 2x, even though it looks like two separate terms, are actually considered one whole term because we are multiplying. So the operation of multiplication and division, always consider that as one whole term. This is also why I said my brackets earlier is considered one whole term. So 3y times 2x, we can just actually multiply the numbers as is. So 3y times 2 gives us 6. And y times x will just give us, well, they can't really do anything, so we'll just end up together as 6y. So that's the first thing. When variables multiply and they aren't the same, they'll just end up together. So always take that into account when multiplying terms. So this is all the way up to distribution. So distribution just means multiplying into a bracket. So something like 6x plus y. So again, keep in mind that, well, actually let's do different variables. Keep in mind that 4a is the same as 4 times a, and you can also apply the reverse, so 4 times a is just 4a. So with this, we can distribute numbers into, or we can distribute a value into a set of brackets. So if we multiply 6 in here, 6 times x will just give me 6x. And if we multiply 6 into the other one, it will just be 6 times y, which will give me plus 6y. So distribution is all about multiplying whatever's outside the brackets into the set of brackets, or the brackets, all the terms inside the bracket. So 6 will have to multiply by everything inside. This also includes negatives. So negative 3 times y minus 2. So negative 3 times positive y will just give me negative 3y. Again, because numbers and variables, when they multiply, they just end up together. And negative 3 times negative 2, negative 3 times negative 2 will just give me positive 6. Okay, don't forget, negative times negative is positive. Yeah, so numbers and variables, when they multiply, they'll just come together. This also includes when something like 2x times y minus 4. So 2x times y minus 4. This just means that the x will multiply along with the 2. So the 2 times y will just give me 2y, and the x will just come along, forming the new term of 2xy. So whenever letters multiply, they just end up together. And then 2x times negative 4. 2 times negative 4 will just give me negative 8, and the x will just come along. So multiplying just basically puts all of our numbers and letters together, and that only applies to multiplication and a little bit of division, but we'll do that next. So what you can expect from some or questions like this is that it will usually be 2 sets of brackets that you have to distribute and then group and add up. So all that algebra, and to be honest all of math, is it'll just be using the things from before. So even though this question starts with distribution, we actually will still end up having to group or find the like terms and grouping them together. So it's all about combining the things that you did before with whatever you're doing next. So now we just need to multiply this 5 in. So 5 times a and 5 times c. 5 times a is just 5a, 5 times c is just plus 5c. Don't forget the signs. Like with this one, negative 2 times a gives me negative 2a, and negative 2 times negative b will give me positive 2b. Right, so don't forget the negatives again. And now we can just rearrange this so that the like terms are together. So 5a, there's only one other a, and that is the negative 2. So we'll just put it next to it. The next term is 2b, and the next term is 5c, and we haven't done anything with that, so we'll just bring that along to the next line. So 5a minus 2a gives me 3a. 2b, nothing else we can do with that, so we'll just bring them along. And 5c, nothing else we can do with that, so we'll just bring that down. And that is your final answer. So we are still grouping the like terms. It's still the things that we did before. It's just that we now had another step before that, and that is distributing the brackets correctly. Remember that brackets, whatever's outside the brackets, will just multiply by everything inside that pair of brackets. So another one more example. Let's do x times right. So x times 5y plus 3. Same story. We need to multiply this x into everything inside the brackets. So x times 5y just means that the x will join alongside it, so that'll become 5xy. X times the 3 will just come together, so that'll give me 3x. Y we multiply in, y we multiply into the 2, but this is negative y, so this will end up being minus 2y. So again, negatives, extremely important. Always bring it along when you multiply, even if there's no number next to it. So then we're going to multiply this negative y into the negative 3x. So negative y times negative 3x will give us positive, because negative times a negative gives us a positive 3xy. So again, now we're grouping, we're back to grouping. If we look at the xy, there's only one other for the 5xy, and that is the 3xy, so I'll just put that together. And then 3x is nothing else like it, so we'll just bring that down. And minus 2y, there's nothing else like it, so we'll just bring that down. So then 5 plus 3 will give us 8 xy plus 3x minus 2y. There's no other like terms, so we cannot do anything else with the sum, and that is our final answer. So this is distribution, and distribution also has its division version. So this is all about multiplication, but there's also one for division. This one is less common, but it is still possible. And it does use, again, some rules from fractions, because they'll start saying divide less and they'll start showing fractions more. Just don't forget that a fraction is another way of writing divide. So let's just look at the, an example fraction of 3 plus 5 over, let's say, 50. So all this is, I'm actually not saying, let me do that the other way around. Oops. Open my mouse. Oh yeah, 1 second, my mouse is acting up. Yeah, sorry about that. So 4 plus 8 over 2. So the way we're doing this is just adding the 4 and 8, right? So 4 plus 8 is just going to be 12 over 2, and 12 over 2 is just 12 divided by 2, which will just be 6. But let's write this in a different way real quick. Remember, the only reason why something can add in a fraction is because it has the same denominator. So you cannot add or minus fractions unless they have the same denominator. So using this, we can actually do this in a slightly different way. So 4 plus 8 over 2 we can actually rewrite as 4 over 2 plus 8 over 2. Now, it's still the same thing, because if we were to go in the reverse, we would just add the numerators. 4 plus 8 over 2 will just be what we had before, and we'll still end up with the answer of 6. But we can actually just break it up in this way, by writing each term over the denominator and getting an answer for that. So then 4 divided by 2 will just give me 2, plus 8 divided by 2 will just give me 4. Look at that, it gives me the same answer of 6. So we're going to use this property in distributive division. All we're doing is we're breaking up a fraction that has an addition or subtraction sum. We're just breaking it up into its parts with the same denominator. So 6a plus 3b all over 3. So we can't really do any adding here. Again, the reason why this worked is because these are just numbers. We can just add them and get an answer, but we have variables, so we can't do anything with them because these aren't like terms. That's an a and that's a b, so they aren't like. So what we'll do is we'll break them up. So 6a over 3 plus 3b over 3. So all I did was break up the brackets into these parts here. It's still the same thing as before, it's still the same denominator, and if we were to add them, we'll just get what we have before, but we don't need to do that now. All we need to do is just divide each fraction. So 6 over 3 can just be written as 2, because 6 divided by 3 is just 2, and we can't do anything with the a, but we'll just bring it along. So just like with multiplication, even though nothing really happened, let's get this one here, even though 4 didn't really have an x, when we multiplied it out, it would just come along. Same thing for the division. 3 didn't really have an a, but we still divided the numbers as is, and it just came along. The same thing's going to happen here. 3 divided by 3 is just going to give us 1, and b will just come along, so then answer will be 2a plus 1b. Right, so again, we're just using the rule that we had before to get a simplified answer. So again, algebra, they're going to combine things we did before. So let's do 4 times minus 2x plus 5c all over negative 5. So now we have something that's really different now. So what you want to do here, yeah. So what you want to do here is distribute the top like you normally would, right? And also in general, when it comes to fractions, don't be freaked out by them. What you should always do is try and segment them up in 2 parts, and that's, well, the numerator and the denominator. So whatever's happening to your denominator, you should work that out. Whatever's happening to your numerator, you should work that out first, most likely, and then move on to the part where you have to do something with the fraction. But try and forget the fact that it's a fraction. That only applies in a later step. I'm sorry, you should only worry about it in a later step. So if we distribute this numerator, we will multiply 4 in. So this will be 4 times negative 2x, which will just give us negative 8x. And 4 multiplied into the plus 5c will just give us 4 times 5 will give us plus 20c. This is all over negative 5. So now we're going to do again this breaking up of this fraction into its parts. So negative 8 plus 20 over 20c over negative 5, we can just break it up as negative 8x over negative 5 plus 20c over negative 5. Right, still the same thing. They have the same denominators, so if we were to add them, we just have the answer from before. But now we can get an answer for each of these here. So I'm actually first going to focus on the second one. 20 divided by negative 5. 20 divided by negative 5 will give us negative 4, and c will just come along. I'm going to write these brackets. You don't need to show the step, but I'm going to show it to you just to explain the answer. And 8 divided by 5 can't really divide. So we'll just leave that as an answer, but we have negatives here. So a negative divided by a negative will just give us a positive. So then negative 8 over negative 5 will just become positive 8 over 5x. Right, or 8x over 5, it's the same thing. So I'm not going to do anything with this one right now, I'll just bring this down. But this is plus negative 4, and a plus and a minus makes a negative, so that just becomes negative 4c. So this is all technically part of distribution, it's just that this one works with fractions or division. So always, when it comes to fractions, just segment them up into the top part and the bottom part, the numerator and the denominator, work whatever is happening in the numerator out, and then continue as you would in a simple sum. Okay. So let's do some more fraction and distribution combinations. I'm running out of space here. Let's do this is going to be a bit of a big question, but it does combine everything that we did before. So minus really big one, but again, the fact that it's a fraction isn't the hard part. It's that we need to make sure that whatever's happening inside the fraction is worked out first before we even bother dividing or breaking up the fraction. So let's just sort out what's happening in the numerator first. So each side we have a distribution happening. So what we'll do is we'll just distribute each side, each part correctly. So 3x times 4y will just give us 12xy, and then 3x times negative 6z, so 3 times 6 give us 30, but remember that's a negative, so that becomes negative 30, and the x and z will just come together. Minus okay, wait, 5 minus. So that's our fraction, or that part of the fraction completely distributed. So let's move on to the next part. Negative 5 times 10. So negative 5 times 10 will just give us negative 50. And because there's no other variables, that'll just come along. So it'll be xy minus 5 times 4. But this is negative 5. Negative 5 times negative 4, which will just give us positive 20, and since there's no other variables, that'll just come along, and this is all over 2. Alright, so again, we haven't even worked with any part of the fraction yet. We're just focusing on the one part, and that is the numerator. So focus on one part at a time, and the more you do that part, it'll probably lead you to something else that you need to do. Like in this case, we now have a grouping that needs to be done. So I'm not going to rewrite that whole expression down. You don't need to rewrite the entire expression, or sorry, the rearranged version. You just need to continue on as long as you group it correctly. So xy can group with this xy right here, and xz can group with this xz right here. Okay, so 12 minus 50 will give us minus 38 xy. Is that? Yeah. And then minus 30 plus 20 will give us minus 10 xz. So I'm using different colors to show like terms. When you answer the question in your book, you can just underline them with the same thing, as long as you make sure that they are the correct like terms that you're underlining or putting them in boxes. They won't necessarily mark you wrong, but you just need to make sure that you are selecting the right ones. And again, we haven't done anything with the fraction just yet, so that just comes along with it. And now we have something similar to what we had before. We have two things being minus, so we just need to break them up. So minus 38 minus 10xc all over 2, we can just break this up as minus 38 xy all over 2 minus 10 xc all over 2. So here's a quick note on this part right here. If I'm just saying, if the numerator is minus and the denominator is positive, you can just make the entire fraction minus. If you say negative 10 xz over 2, you should turn that into plus. It's complex, but the important thing is the sign should still make sense. So negative over positive will just give me a negative, and plus negative will just give me a negative, or instead of that, we can just say minus this entire expression, because this entire expression now will be negative. We're going to do the same with this one. Instead of saying negative 38, we can just say 38 over 2 and make the entire thing negative. Both is correct as long as the signs make sense. So 38 divided by 2 is 19, but this is negative 38, so we'll say negative 19, and since nothing happened to xy, we'll just bring it along. And 10 divided by 2 is just going to be 5, so that just becomes 5xz. Nothing happened to xz, so we just bring it along, and this is my final answer. And this is kind of the most extreme version of what they could ask you for this, where they combine both the distribution of multiplication and division. But the important thing is, again, fractions is nothing but you should always look at it as two parts to one sum. So just focus on the numerator and work that out as much as possible. Just keep that as a fraction. And once you've worked out the numerator as much as you can, then you need to worry about the fact that it's a fraction and do this breaking up. Yeah, so what I'll do now actually is we'll go through an example exam question. Let's say for term 3, because I believe that's when most of you guys should be doing this, or sorry, term 2. But if you haven't done it in term 2, you'll definitely do it in term 3. Let me just get this up real quick. So firstly, do this question. Again, this is straight from the exam, so the reason why I tend to use exam papers is because your teacher is also most likely just to refer to another exam and use that in their own exam. So actually, wait, I want to use a substitution one as well. Let's get a substitution one. There we go. Okay. Alright, so this one's perfect. Okay. So here we have an example of an exam question. So given the algebraic expression below, use the expression to answer the following questions. It's minus 10x to the power of 3 plus 10x plus 12 minus 3x to the power of 2. So how many terms are there in the expression? Again, terms, you can just identify a term by something that's separated by either plus or minus. So here we have minus 10x, and it's being added to 10x, and 10x is being added to 12, and 12 is being minus from 3x squared. So we have a total of 4 terms. So we have 4 terms in this expression. Right, 2. I'll actually leave all these working out here because it's fine to have this working out on your paper. So now we need the coefficient of x squared. So let's first identify the x squared. This is my x squared right here. And the coefficient, like I said, is the number in front of our x, in front of our variable. So my variable is x squared, and the number in front of it is 3, but not just 3, it is negative 3. So my answer here will be negative 3. Always include that sign. Write down the constant term. The constant term is the term that does not change, or the term that doesn't have a variable. In this case here, it will be 12. So the constant term here is 12. So 4.14, write the expression in descending order of powers. So that just means we want to write from the highest power to the lowest power. Specifically, we want to look at the x's. Okay, we don't have that much space here actually. Let's blank this one out for now and write it down, yeah? Okay. So write the expression in descending order of powers. So we first need to find out what the biggest power is, and that is to the power of 3. And again, it's descending, so we want to start from the highest to the smallest. So the first answer is minus 10x to the power of 3, right? Because that is the highest power here. The second power will be 2, x to the power of 2. So then we'll have minus 3x to the power of 2. And then even smaller than that, we have x just on its own. And because there's nothing on top of the x, you can actually think of that as a 1, not a 0. You'll be doing exponents malik at some point, but yeah, if it doesn't have anything on top of it, it's just to the power of 1. So that will be plus 10x. And 12 does not have any exponent on its variable, so we'll just say plus 12 as the final one. And this is in descending order of powers because we're going from biggest to smallest. If they would say ascending, then you do the reverse. Smallest to biggest. Also, these are just all the mark allocations. Yeah, also might differ from your school though, depending on teachers. But this is generally what you can expect from your exam. So here we have a substitution question, if x is equal to -2 and y is equal to 3, calculate the value of 3y minus x all to the power of 2. So it's good practice to actually just write down the expression you'll be working with, mainly because it stops you from basically having to look up at your paper again if you're writing on a separate paper. So just write down the expression as is and then write down this piece of information here. So we have x is equal to -2 and y is equal to 3. So this is going to be a lot of bracket work, but it is important to include them so that you'll do the right thing. So y we know is equal to 3, so I'll put that in brackets. Actually, let's put in brackets here. So this will be equal to 3. And x is just on its own, but even so, we still want to use those brackets. So x, instead of x, we'll write -2. This is all to the power of 2. So again, wherever we see a y, we'll substitute that number. In this case, it's 3, and wherever we see a x, we'll substitute -2. And again, we always want to substitute with brackets just because it's the best way to always make sure that your sign work is correct. So we want to follow some BODMAS rules. So that just means to do whatever's inside the brackets first. So 3 times 3 is 9. So 3 times 3 is 9. Put in brackets as 9. And minus -2 will just become +2 all over 2. All to the power of 2, sorry. So 9 plus 2 is just 11. And again, this is all to the power of 2. So all to the power 11 to the power of 2 will just be 121. So yeah, always look. Excuse me. Always use your brackets when you substitute. It's just the best way to always do the correct thing with your signs, specifically for negatives. Okay, so let's do some grouping and distributing questions. I got a space here. Okay. Actually, I'll just write down each of these questions individually. So the first one we have 3a minus 2b. Okay. So 3a minus 2b, it's just in brackets on its own. Whenever you see brackets on its own and there's nothing outside of it, you can just rewrite it as is without doing any work, because there's nothing in front of it here, so there's nothing to distribute in. So we'll just say is equal to 3a minus 2b, and then minus 3b, we haven't done anything with it, so we'll just bring it down. I also want you to take note of how I write these answers. I'm always writing what it's equal to into the next line. This is also how you will be expected to format all of your answers from later grades, but especially this is where you'll need to learn how to do it. So I'm just writing equal to in the next line, because everything that I'm doing in the next line is equal to what comes before. So I wrote my entire expression. Let's say the question is 1.1. This is my margin. So the question 1.1 is 3a minus 2b minus 3b, so that's the question, and I'll just write the answer in the next line. I must say equal to, and then whatever that is equal to, the next line. And also what this does is it leaves a lot of free space for working out. So basically anything that you do on your right you can consider as working out space, and everything on your left is where your answers will be. So yeah, this is just the format of how you want to answer the questions, especially if you're just writing on a page. So 3a, there are no common or like terms for 3a, so we'll just write that as is. But for b, we do have like terms there. So minus 2 minus 3 will just give us minus 5b. Right, and that is our final answer. We cannot group this anymore, so that is the answer there. So actually, let me continue this then, or just throwing it like this. We have 1.2, which will be 2 over 3 times 9x minus 12 is equal to. So one important thing about how they ask exam questions is they won't, most of the time they won't say specifically this is distribution or this is like terms. They'll just say simplify or get an answer, something along those lines. So that's something that you need to take into account from now on. They probably won't say exactly what you need to do. They'll just say get an answer for this, basically, by saying simplify or answer the following questions. Yeah. So 2 over 3 times 9x minus 12. So even though this is a fraction, we are still going to apply the exact same rules of distribution. The exact same rules of distribution. So we're going to multiply this 2 over 3 in here. So again, this is why it's good to have this open space on the right. So 2, let me do it in blue actually. So 2 over 3 times 9x. So 2 over 3 times 9, whenever we multiply a fraction and a number, we can just multiply the numerator by that number. So 2 times 9, which will just give us 18 over 3, and the x will just come along. So 18 over 3 will just be 6. So that will give me 6x. So there was a whole lot of work there that you just did on the side, but you can immediately just write the answer in here. So again, this is why this format is useful. You'll just have specific areas of working out. You can write it in pencil, you can scratch it, you can erase it afterwards, but usually everything on your right is just working out. So for the next one we have, let's do this in red, 2 over 3 times 12. No space, let me just zoom out a bit. Okay, so 2 over 3 times 12, I'll just rewrite it here, 2 over 3 times 12. So again, we're just going to multiply the numerators by that number. So I just want to make sure you can see everything fine. Yes, okay. So 2 over 3 times 12. 2 times 12 is just going to give us 24 over 3, which will just give us 8. So it just means that 2 over 3 times 12 will give us 8. And then 6x plus 8, you can't do anything else with that because those are both terms, those are both unlike terms, so you cannot group them at all. Yeah, so again, this format, really important or really useful. It just allows you to keep your working out and your actual answers on different sides of the page. Let's do 1.3. Should be 2 times a minus 3 minus a minus 5, all in brackets. Okay. So 2a minus 3 minus a minus 5. Again, they won't say distribute this, they'll just say simplify or get an answer for. So, what we need to do here is multiply the 2 in. So 2 times a and 2 times negative 3. So 2 times a will give me 2a, and 2 times negative 3 will give me minus 6. Now we need to make sure this bracket is distributed correctly. So whenever there's a negative outside the bracket, you can just bring that in. So negative and a positive for a. Negative and positive a will just give me negative a as an answer, and negative 5 will come together to make positive 5. So 2a, there's only one other a and it's this one, so we'll say minus a. And minus 6, there's only one constant, one other constant, and that is plus 5, so we'll say plus 5. And again, this step you don't need to show always, you can just basically add a line all your like terms, and they get answers like that. But yeah, you can do this rearranging if it helps you. So 2a minus a will give us just a on its own, because we can just minus the numbers in front since they're like. And minus 6 plus 5 will give me minus 1. So my final answer here is a minus 1. And again, if you were ever unsure of how to do this, you can do it on the right, work that out, and just write your answer here. So this is my margin that I'm drawing with each part. Just make sure, and also your equal to can be in the margin if you'd like. You just need to make sure specifically that it's underneath and the next line of work. Okay, so let's move over to this side. Okay. So 1.5. We have 8a plus 6a squared minus 2a. Let's do the line a bit better. So we'll have a negative 2a. Okay. Oh, this is just, sorry, not 8a, just 8. Sorry about that. There we go. Okay. Okay. So again, this is just all under the same section of algebra, but they won't specify what sort of algebra you need to use. So now we have a fraction that we need to break up. So we'll say 8 over minus 2a plus 6a squared all over 2a minus 2a over minus 2a. Okay, so when it comes to dividing numbers in variables like this, the first thing I always want you to try and look for is things that cancel out. Things that cancel out doesn't give you 0, that's the first common mistake, it actually gives you 1. So 2a and 2a will just cancel out, and since this is minus 2a over negative 2a, we can just rewrite this as 2a over negative 2a, we can rewrite as 1, negative 1, sorry. So again, I'm putting this in brackets so that I don't lose track of my negatives here. So 2a over 2a will just give us 1, and since it's a negative in the denominator, it will just become negative 1. So I'm just putting the brackets there so I can keep track of it, and remember when things cancel out, they give us 1, not necessarily 0. Especially when it comes to division like this. So next we have 6a squared over 2a. Oh, actually this is just a. So 6a over 2a. So 6 over 2 is just going to give us 3. But importantly, a and a, it's a divided by a. A divided by a will also just cancel out, giving us 1. So you can either say 3 times 1 or just 3. They both are acceptable. I'll show the times 1 just so that you don't lose track of that. But yes, a divided by a will just give us 1. Don't forget, anything over itself is just 1. So the particular reason why I went backwards in this case is because 8 over negative 2a is actually it's actually going to be a bit different to what you've done before. So what I'll do is I'll do some working outside. So before we just had, actually a different color. So before we just had the variable in the numerator and just a number in the denominator. So 6x over 3, 6 divided by 3 is just 2, so that just becomes 2x. This is very different to 6 over 3x. So again, 6 will divide by 3, definitely. So that just gives us 2. But x, what is x the denominator of? It's a bit hard to see, but you can actually just say that's just 6 times negative 1. And x will need to stay in your denominator because the division function is still happening. And it's always something divided by x. So we'll have to say 1 over x, which we can rewrite as 2 over x here. So it is a bit confusing, but importantly here, it's always the operation of dividing by x, while this is x divided by. This is x divided by 1. So this is just 2x. While this is 1 divided by x, so we'll just put the number on the top and the x will need to stay at the bottom. So the same thing is going to apply to 8 here. So 8 divided by negative 2 will give us negative 4. And since it's being divided by a, that will just stay in the denominator. So minus 4 over a will just come along, will just come down because there's nothing else we can really do with that. But for 3 times 1, it will just be 3, and negative 1 times negative, or negative outside of this here, just turns into a positive. So here we'll just have negative 4a plus 4. And there's nothing else you can do with this because there are no other like terms. Okay, so just recapping it. We are doing the distribution for a fraction, and in this case we didn't have to do anything with the numerator, so we just need to immediately break it all up. So 8 plus 6a minus 2a all over negative 2a. Mistake there, sorry about that. Yeah, sorry, I missed the negative here. So instead of 6 divided by negative 2, this will just give us not positive 3 but negative 3. So negative 3 plus 1 will give us negative 2. There you go. Just going over it again. We can break this all up by putting the denominator under each part of the fraction. So 8 over negative 2a, 6 over negative 2a, and 2a over negative 2a. And again, we'll just put the actual operation of what's happening in front of the fraction. So plus 6a will just come in front here, minus 2, the minus will just come in front here, but we are still dividing by negative 2a. So, with this one here, when things cancel out, they don't leave 0, they leave a 1, and since this is 2a divided by negative 2, this will just give us negative 1. 6 divided by 2, or negative 2, will give us negative 3, and the a's will just cancel out, leaving us with 1, not 0. You don't have to put this 1 here. I just do this out of habit to show you that they don't leave 0, they leave 1. Because another mistake here is that people cancel this out completely and don't add anything underneath. Cancelling out means leave 1. So then, negative 3 times 1 will just be negative 3, and negative of negative 1 will just give us positive 1. Now see the 8. 8 divided by 2 by negative 2 will just give us negative 4, but since the a is at the bottom here, it needs to stay at the bottom, because we're still dividing by a. So then, negative 4 divided by a will just stay the same, and we just need to group like terms here, which is the negative 3 and the 1, which will give us minus 2 as the answer. And this is your final answer here, because there are no other like things to group. So it was a lot of work, but it's just everything that we've done before with a little bit more thinking involved. And again, they aren't going to say specifically use the distribution of division. They'll just say simplify the following, which is what they'll do for all of your algebra. They'll just say answer this question. You need to get used to trying looking for the steps you need to do. 1.5. So next we have 3a. Sorry. Subtract 3a minus 2b plus 1 from 4a minus 5b minus 2. Alright, so again, the word from just tells us where we should start, or in other words, what comes first. So this just means that 4a minus 5b should come first, minus 2, and we are minusing this entire term, so we say minus the entire term of 3a minus 2b plus 1. Right. I'm not going to do the other method because the other method gets more and more complicated the more terms there is in one expression. So when it comes to like 3 terms, it's probably not worth doing. You just need to remember for this method to put brackets when you minus. So start from, or start with the from and minus whatever's next. So we aren't doing anything with this just yet, so we'll bring it down, and now we need to bring this negative in. So negative of a positive will just give us a negative 3a, a negative of a negative will just give us a positive, and a negative of a positive will give us a negative. So all I've done was just bring in this negative here. Just highlight it a little bit. I just brought in the negative for each of the signs there. So now we do some grouping. Is there another a? Yes, there is, so I'll write that next. And then we have minus 5b. Is there another b? Yes, there is, so we say plus 2b. Here we have negative 2. Is there another number on its own? Yes, there is, so we write negative 1. Okay, so 4a minus 3a. Again, I like them, so we can just minus them. So 4 minus 3 will just give me 1a. B and B are like terms, so minus 5 plus 2 will just give me minus 3b. And minus 2 minus 1 will give me just minus 3. And this is my final answer for this one. Yeah, so algebra, or everything we just did, what makes algebra hard, especially in these contexts, is that they just stack everything together. So if ever you're trying to look for what to do in algebra, don't look at the bigger sum. Look at the smallest sum first, because what makes an algebra sum hard is not necessarily the fact that it's big, but the fact that it uses everything that you did before. And this is especially true when it comes to distributing. So always first start with the smallest step first. Let me show an example of that with this part right here. So for something like distribution, we'll start real simple with just one bracket on its own, and everything will multiply in. We'll add negatives, and it gets a bit harder from that point on. But then we'll have 2 brackets that we have to distribute out, and then group afterwards. So it is still everything that you did before. We are just combining, or we are layering steps. So study each part individually, the distributing, the grouping, study each of those individually, and then look at the sum and try and spot what you should do first. I'm not going to say that there's no wrong way to do an algebra expression, but there is usually something that you want to start with. So brackets is probably always where you want to start. Same applies for fractions. Again, don't be fearful of fractions. All that it is it's two parts of the same sum, and that's the numerator and that's the denominator. So again, when we have two things being added in a fraction, we can just rewrite it as its separate parts and get an answer for each part like that. Also, this is 1b, so nothing there. And in this case here, we had a distribution over a fraction or over a number. So again, just distribute how you normally would, and then split the fraction up. So now we're back to what we did before. And again, always negatives. When you have negatives, use those brackets, because brackets is the best way you can guarantee, or it's the best way to make sure of you doing the correct negative operation. Same applies for substitution. Substitution is just their way of testing if you know how an expression or how a term works. So if something's together, like an x and a y is together, that just means it's the x and y multiplying. If there's a number right next to a variable, that just means it's a number multiplied by the variable. If there's an exponent on the variable, it just means it's to the power of. So in this case, we have x equal to 2. So just 2 to the power of 3, and the entire x will be negative afterwards. Because again, x is just positive here, so we just need to put that x in brackets. Yeah, and then it's just make sure to do your negative work correctly, and follow BODMAS, which we will be doing a bit later on in the week. Right, is there anything else? Yeah, also don't forget your terminology. I'm going to be using these terms a lot, and Malik will also be using these terms when he does his work. But again, don't forget the terminology. Variable is just an unknown letter. Constant is just a number. Term you can easily spot by just adding or minusing, but a bracket will be considered as one whole term. Coefficient is just a number in front of the variable, and degree is just the highest exponent in an expression. Oh, an expression is just a sum, an algebraic sum. But alright, thanks for watching, everyone. We have a good day onwards, and yeah, have a good day.